This is an AQA GCSE chemistry question. It's from the Trilogy paper 2019 and it is a higher question. The topic of this question is electrolysis. Pause on each section, have a go at each part and then review once you're done. So here are parts A and B. Here's part C, part D, part E, part F, and finally part G. And in total, this is a 4-mark question. So let's go back to the beginning. The question is about electrolysis. Some metals are extracted from molten compounds using electrolysis. Why do we use electrolysis to extract some metals? It's a good question because it is very expensive, very high energy costs. So we will only do it when we have to. And we do it when the metal is more reactive than carbon, when the metal is higher in the reactivity series than carbon. And another way of looking at it is that those metals their oxides cannot be reduced using carbon. Aluminium is produced by electrolysis of a molten mixture. What two substances does the molten mixture contain? Very, very important fact to remember here. First one it contains is aluminium oxide. The ore of most metals is the oxide of that metal. This will be electrolyzed and this is where the aluminium comes from. But the other substance is really important too. And it's cryolite, molten cryolite. The purpose of it is the aluminium oxide dissolves in the molten cryolite. So the ions are free to move. What's important about it is cryolite has a much lower melting point, and that reduces energy costs considerably. Let's take a look at these. Copper and chlorine are produced when molten copper chloride is electrolyzed. Complete the half equation for the reaction at each electrode. So we know that in electrolysis we make the elements, but it's actually telling us that here as well. We're making copper metal, we're making chlorine gas. So I'm going to go from Cu plus 2 to Cu. The way we're going to do that, we've got a plus 2 charge here, a 0 charge here. I need to balance the charges. I do that by adding electrons. I need 2 of them on the left-hand side. As a bit of additional information, the copper ions have gained electrons, which makes it reduction. The 2Cl minus are going to go on to make Cl2. To get this, we've got to remember that chlorine is a diatomic molecule. Very, very important. And I'm going to remind you, as I do on many questions where this comes up, that if you look at N on the periodic table, go across to F and go down, all of those elements are diatomic, as is hydrogen on its own on the left. There's a little sort of abbreviation you can use to remember it, and that's H-NOF Culbriat. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, astatine. All of those are diatomic. Now again, we've got to balance the charges. -2 on the left. So this time I need -2 on the right. 2 electrons. These electrons have been lost, which means the process here is oxidation. We're going to move on to part D, and we have got some apparatus set up. Copper chloride solution, pure copper electrode. Measure the mass of copper deposited on the negative electrode after 60 minutes and compare the mass deposited with the expected value. Now this is because we are shifting impure copper onto the pure copper electrode, so we'd expect it to go up, and we'd expect it to go up by the same amount as the positive electrode goes down. So, why might it not be the same? There's more than 2 answers you can give. The concentrations might have been measured incorrectly. It might be you didn't have 1 molar, you had 1.1 or 0.9. It might be that the copper that was formed on there fell off. You might have lost it when you were drying. It might have been lost into the solution. There might have been a timing error. You may not have done it for exactly 60 minutes. And it might be there were impurities in the solution. There are lots of ways you can answer that question. Bit of a calculation here. We have got time in minutes and we are being asked to determine how much copper we would expect to make after 24 hours based on this information. Well, I think the easiest way to do this is to go to 30 minutes. I'm going to go to 30 minutes. I'm drawing my lines in so we can see, and that comes to 5.4. After 30 minutes, 5.4 milligrams of copper are formed. Now that, because it's a straight line graph, we can multiply up, extrapolate to 24 hours. So for example, after 60 minutes, I would expect it to be double that, 10.8. After 24 hours, I would expect it to be 48 times the amount in half an hour, taking me to 259.2 milligrams. On to part F. And we are being asked to determine the mass of the negative electrode at the start of the experiment. This is straightforward graph reading, 4.75 grams. And then we are going to work out the gradient. So we have got 4.75 on the left, we've just calculated, and this is 7. So my change in Y on here is 2.25 grams. If I've done that for the whole of the line, it makes the next bit easier because my change in X, it's gone from 0 to 10. 10 hours. And now I can calculate my gradient, which is change in Y divided by change in X. And that gives me a value of 0.225, but I need the unit as well. We're dividing grams by hours, so the unit is grams per hour. And that takes us to the end of the question.